see how a test cross can tell us about the percent recombination that occurs between two loci. In this case, it's a test cross because we're using one parent that's homozygous recessive for alleles recessive B and E. So what we know is that this parent can only pass on a recessive B and recessive E to its offspring. That's all it has to give. So the real question is what the first parent passes on. We know that it could pass on a chromosome just like this, with B and E together. We know that it could also pass on the other chromosome with recessive B and E together. So both of these would be considered parental genotypes because they inherited the same chromosome that came from a parent without being exchanged. However, if recombination occurs, I will generate a new chromosome. In this example, we could imagine the chromosome exchanging, the sister chromatids exchanging genetic information, in which now I would pass on a chromosome that's a big B and a little E. It would still get the same chromosome from the other parent. Recombination is always a homologous exchange. So if I generate a dominant B recessive E chromosome, I also have to generate a recessive B dominant E chromosome. So these offspring would be the recombinants. Now the question is, how many of these are there? Let's say, for example, that there are 80 parentals and 20 recombinants. Well, what that tells us is that there are 20 recombinants out of 100 offspring times 100% gives us 20 map units or 20 centimorgans.